Hi, I'm Nancy Berliner from HPE Technical Marketing Engineering. This video will explore active peer persistence, HPE's new transparent failover feature for HPE Alletra 9000 and Primera storage arrays. In the demo, I'll show how easy it is to set up, demonstrate how the pathing works, and then do an automatic failover. Active peer persistence shares its DNA with its predecessor, classic peer persistence. They both involve two storage arrays replicating synchronously, where failover is automatic and completely transparent to the hosts and applications, with an RPO and an RTO of 0. Where active peer persistence differs is that hosts never need to traverse the inter-site links to access their data. Both reads and writes happen locally to the source and target LUNs. It works because both LUNs have the same worldwide name, but the local preferred paths are designated as active optimized, while the remote paths are active non-optimized. And for writes, the array software has the intelligence to maintain the write order fidelity. The end result is significantly lower latency to the hosts and less utilization of the inter-site links. Active peer persistence is available for HPE Alletra 9000 and Primera storage arrays, where any model of either type may replicate to any other model. For this demo, I have two sites which I'll call Site A and Site B. I'm using Primera storage for this demo, and there's an array and a host in each site with a vSphere Metro cluster between them. Right now, the only I/O is from two VMs in a data store in Site A. To make it a little easier to keep track, I've made the host and storage names in Site A use the lower numbers. The Primera system is 3038, and the host ends in -40. In Site B, it's S3044 and host -43. And to save some time, I've already set up the replication links between Primera systems. In the demo, I'll simply create the remote copy group, and the system will take care of the rest by automatically creating the target LUN, presenting it to the host in Site B on an active optimized path, and by creating the active non-optimized paths between sites. Here I am at the dashboard of the SSMC Management Console. And here's the remote copy configuration that defines the links between the two storage arrays. Since the links are bidirectional, the remote copy group is where you specify which system is the source and which the target. If I already had target volumes, I could select them manually, but I find it easier to let the system create them for me. With peer persistence, the system automatically creates a target volume with the same worldwide name as the source so that it appears to the host as a single volume. The auto-synchronize and auto-recover settings tell the system what to do after a failover. We want to reverse the direction of replication and restart it when the systems can communicate again. I don't need to enable these settings here though, because when I select active peer persistence, all the failover settings are automatically toggled on. Next, I'll add the source volume. It's possible to add up to 200 in a single peer persistence group, but I have just the one VMware data store. If the volumes are exported to a host or host cluster, as mine is, the hosts are automatically populated below. This makes it easy to choose the proximity settings, which will determine which paths are optimized versus non-optimized. The host whose name ends in -40 was in Site A with the primary system, and so this host will be primary. The host whose name ends in -43 is in Site B and will be secondary. That's all there is to it. The LUNs on both source and target are writable and exported to both hosts. In the hosts dropdown, you can see the proximity defined for Site A and Site B, and you can monitor the syncing progress in the volume pairs dropdown. The auto-generated target volumes have the same name as the source, but with .r appended to the end. As I mentioned earlier, With active peer persistence, both reads and writes are serviced by the local array. In my setup, both VMs are on the host in Site A, and so all I/O is to S3038, which is local to that site. But if I vMotion one VM's compute resource over, well, let's go back to the demo and see what happens. First, let's look at the pathing. In vCenter for that data store, all paths to both LUNs are active, but only the active optimized paths are active with I/O. The Primera CLI shows the same thing. At the top of the screen, S3038 in Site A has active optimized paths to the -40 host and active non-optimized paths to the other host. On S3044 in Site B, it's the opposite. The active paths are between the target LUN and the -43 host. Since both VMs are in Site A right now, all the I/O is from a single host to S3038, as you'd expect. Now let's move some of the workload to the other host. My two VMs are here at the bottom of the list, and I can vMotion one of them to the host in Site B. You'll notice that it's only necessary to migrate the compute resource. I'm not changing the storage at all. I'll fast forward until it's almost finished, and the second it does, the I/O becomes distributed between the source and target LUNs on both storage arrays. Up until now, we've been assuming that Site A and Site B are at some distance from each other. And most times they are, so you'd choose primary and secondary as the host proximity settings. But suppose you have only a single data center, and host latency is the same to both storage arrays. In that case, you'd want to load balance among all available paths. That's the purpose of all, the third host proximity option. I can change the setting online, and voila, the I/O is now evenly balanced between both hosts on both arrays, and all the pathing is now active. For the final part of the demo, I'm going to simulate the failure of the entire array. If the primary array fails, the secondary will of course lose communication over the replication links. And it is up to the secondary to initiate the failover. But how does it know that it's a true system failure and not just that the links are down? For that, you need an independent arbitrator, ideally in a separate site. We call that the quorum witness, and it communicates on a different network via the array's management ports. This allows the secondary to verify that the primary is truly unresponsive, and it can initiate the failover. The quorum witness pertains to the remote copy targets, not the group, and I set this up prior to the demo. I've returned the host proximity to primary and secondary with one VM still in each site. Then to simulate the failure, I have two additional CLI sessions, one to S3038, where the control port command will bring down its replication ports. And on the Linux VM that's hosting the quorum witness, I'll issue a command to stop it from communicating with S3038's management IP address. You need to enter both commands in quick succession, and if you look to the right, after only a few seconds, you can see the workload fail over to the secondary array in the CLI session on the bottom of the screen. When S3038 becomes available again, and the links between the two systems are back up, replication will automatically resume with S3044 as the primary. Thanks for watching this demo of active peer persistence for HPE Alletra 9000 and Primera storage. For more information, please visit hpe.com/storage.